So to express what we are about to see, we're gonna talk about this scooter lesson that introduces you to the most powerful, to the very few powerful tools that are very common in every data science analysis. So let's go back to the lesson here. Remember, as in any challenge in this workshop, we are working with pull requests. So we do a pull request, each challenge in its own pull request. I already set it up before the pull request, so it's here. So it's called not skateboard. I'm gonna work with scooter. So scooter is the PR that I want to work with, and if I want to make sure that this PR has every change that the upstream repo has, so if I want to synchronize my work with whatever has been happening the latest minute in the single source of truth, which is the owner's repository, the upstream repository, then I run PR pull upstream. I should now have, and I do have, for example, changes that have emerged recently, like the file that Laura added. And that file, if I render that file, if I inspected that file, it should have, all her changes. So that file works. And for example, it includes the author, Laura, which is something that I discussed with her in a pull request. I reviewed her pull request. She added that change, and it's now reflected in my own repository locally, right? So that's the beauty of collaborating with GitHub in a distributed way. So GitHub is, the hub for centralizing our work, and then the workers are distributed physically. No matter where they are, they can use these setups that we have been discussing to share their work, to work collaboratively. And hence is the importance of understanding a little bit of it. So, but going back, so that was a little bit of a wrap up. What I have also done to kick off this challenge is I have copied the file 02 scooter _ your name or _ you as 02 scooter _ Mauro. So that, and then I initialize, I push the pull request with PR push. So just to be sure, I could do that now. PR push. Oh, it's saying that there are uncommitted changes. That's a good kind of error to kind of debug live. So what's happening here is that I asked to push stuff, but in the Git pane, as you can see, I have some changes that have happened that I have not committed. So this file appears as modified. There is a file in the staging area, has changed. I put that file, or it was put in the staging area by Laura, and now it is available there. But Git records that it has been changed. Why? Because I opened her file and I hit knit, so I kind of refreshed her markdown file. So what I want to do is I want to forget about that for now, because that's not the focus of this PR. So I'm going to revert. I can do that with the opposite button of your mouse and click revert. And that should remove the changes. Right? So now I can say in the question that this is asking me, I could just say nope, that I want to kind of abandon this and try again. So let's do PR push again now, and now it should work because there is no uncommitted change in the staging area. Everything, the staging area is completely clean. So if you look at your theater in the stage, there is nothing, it's empty. You're ready to start creating your next snapshot. But let's open the file that we want to work with. So in my case, it's going to be Scooter Mauro. And let's see what it is like. So again, I'm gonna expand this to use the whole screen. But so that I have here to the right the output of this and kind of guides me a little bit. But I invite you to use the right hand side in this case of the screen for your own RStudio. As usual, we start by collapsing everything with Alt O, or if you're on a Mac, Command Option O, but we can also review now, expand things to review. Now you can see how the header of the rmarkdown document looks a little bit more complex, I won't talk about this right now. First, I want you to experience the magic, and then I'm gonna break it down. Also, I want to review this idea of setting options for your rmarkdown document at a global level in a chunk called setup. That's almost. You should probably include in every rmarkdown document some setups that show the options that you like. This one in particular, the collapse, is useful in that it puts the code and the output in the same output chunk. If I change that to false, I explain it because it's a little subtle. If I change that to false and knit, you will see that the code appears separately from the output. There is a little white line here, a little gap. Sorry if you are, so what I intended to do is to show this. So by changing collapse to false, now the code and the output are separate in little output chunks. And that's fine, but it takes, to my taste, it takes too much space. And I don't need that really. I want something more close to the experience that I have here on the console. But you develop your taste, and you can set those chunk options in the R profile, in the same file where you did edit R profile. In the same file where you added these favorite options that always attach DevTools, you could also set your chunk options, so that every time those options will be by default. So even if I now remove these options, they should still behave like that. I need to restart my session first, but restarting the session makes that those options set globally. So this is even more global, right? Before, actually, it's not being reflected. It looks like it's not being reflected. So, and I'm not gonna debug that right now. So, but long story short, in my own setup, I do have options set up even more globally. I set it at the global level of the entire R. So every time I open R, the chunk options that I like are always available to me. Sorry for not being able to show you on the fly. Probably because I was setting the option actually to true. Maybe it was working. Let's see. Let's comment this out. Let's put it here in the profile again. Collapse true. These are the options that I like. I restart. I go to the file. I hit knit. So this is the same as if I removed it. I hit knit. Let's see if it's working. Yes, it's working. Okay. So what I'm saying is that if you do find options that you like and you don't want to rewrite every time something like this, then you can just open that R profile file, which in use this you can do with the function edit R profile. And then those options will be in every R session. In the same way that use this is going to be available in every R session. So I'm going to remove that because I want to kind of explain this file by file. And so I intentionally take probably a bit long to explain some details, but these are the details that it's an opportunity for me to explain now. So these are the little hacks that you may take years to discover. And I want to pass that knowledge as quickly as possible to you. I know that the focus of the workshop is kind of higher level, and we will cover that. And if we don't, then I'm gonna record sessions without you, and you can watch them later. Okay, so now is like some of the things that this document does are a review, so we don't need to type them, right? So you already know that you started after the setup chunk. You start by attaching packages. You call the tidyverse with library tidyverse. It is also useful to use here. So I do library here. Here is a friend of the tidyverse, but it's not in the tidyverse, so it's not listed in here. So that's why I need to start with here to attach it. And here produces this output saying where, basically what's my working directory. Here starts at and says the directory of this repository in the RStudio Cloud computer that I'm using now. Okay, so how do we read data? Okay, we read data, by creating a safe path with here. And we know that, a good idea is to avoid completely the slashes because, different systems have different conventions, so you just avoid them by separating the arguments, and which is a good opportunity to show you what arguments, how to understand a help file that has this type of argument. So here I am in the help file of here package, and the way I got to the help file is by stepping on the function and pressing F1. So here it is. This is what you get. And notice that the function here, how you use it, it has the argument ... So what does it mean? Well, it is the path components below the project root that can be, and it can be empty as well. So that's the definition. ... means any number of arguments. It doesn't take just one. Remember that, for example, read CSV took the first argument was file, and only in that one first position you could pass the file. With the here function, it is not. It is ... You can pass any number of arguments. So I could say here path to here, and this will create for every argument that I passed, and it could be infinite, right? So I can continue add things to the pass values to the ... argument, and they will be understood. So that's another comment on the syntax. So, okay, let's run that code to actually load the data set, and what we get is the gapminder data with some information about how the different columns have been interpreted. So the reader function is telling us that, for example, the column country has been interpreted as a character, that population has been interpreted as a double, and so on. And now up to the first little challenge. So remember the pipe syntax. So now we are extracting the data set. We are taking it first, because with the pipe we can use the following expressions. We can say take the data and then. So the pipe means then. So you start saying take gapminder and then, for example, what we are asked is this challenge is asking us is to run the function glimpse to have a quick look at the data. So take gapminder and then glimpse it, right? So how did I do glimpse? I started typing and then tab completed. So with that, I run that chunk and I get a preview of the data set that is very succinct, right? It shows the first few rows in a horizontal way. So depending on what's the shape of your data, sometimes it is better to print it as a table. Sometimes it is better to print it, to glimpse it, just to have a look at all the columns. Because the problem with the table is that depending on the, well, not problem, but the challenge is that depending on the size of your window, you can fit, basically you can fit as many columns as fit in your window. If I make my window smaller and rerun gapminder, I only get 4, I mean, it's very clever, right? I only get 4 columns, but then the other columns are here, right? So what would happen if I have this little space and I still want to see a little bit of each column? Well, I can glimpse it, right? And now I see every column and at least one value of each row. So depending on your circumstance, sometimes you want to view the data in one way or another. But the takeaway is that usually as soon as you import any data, you have a quick look at it. And Glimpse is a friend of you. It can really help you. Sometimes you just realize, okay, this column looks really bad, there's something wrong or it's missing, that kind of thing, big things that you can pick up. So now we get to filter some the data to subset some rows. In this case, we are going to choose the rows where the continent is Europe. So how do we go about that? So let's see. So here I think I changed the task. This is a mistake. So I think that I changed what I wanted to say is Americas and Europe. So I want to find the rows in the data set that where continent is equal to Americas or Europe. So sorry for the typo there. That's something I need to fix. So how you do that? Okay, you create a vector if you want. You can do it right away here, or you can do it outside. And in this case, you create that vector. In this case, the vector is called continents, and I can print that vector right to the console here. So as you can see, it's Americas and Europe. And I'm going to use that vector to filter the Gapminder data. So what I'm going to do is I'm going to take the Gapminder data, Gapminder, and then I'm going to filter the continent column. Remember that Gapminder has, let's have a look at the Gapminder again. So you see that continent has a bunch of continents, and that column also has the, actually one view that I forgot to show you is with the view. When you're viewing data frames, you can do view as well, and that will show this spreadsheet-like view that there you can use to very quickly say Europe. So it will Europe. It will quickly find the rows that match what you want, right? So this is a view only, and you want to do that permanently, kind of, right? You want to do it to the data. So how you do it? Okay, so you take the data set and then you filter it to find the rows where continent is one of these elements in the vector continents. So let's run this, and what we get is, as you imagine, only the rows that match Europe or at the end Americas, right? There's no other continent in here, or there shouldn't. That's the solution. Now, notice the following. We have created that continent vector by hand, right? It's part of the analysis, and if there's a stakeholder that was interested in a different continent, it is now hard-coded in my analysis. So that kind of sucks, because if I want to share my report with another stakeholder that doesn't want to open this document and change it, or maybe they don't know R, then they can't get a summary for different continents. However, we can set parameters at the top of an rmarkdown file to allow that feature. So in this case, let's see here. So there is this variable called params that, if you notice, let's go to the top, matches this name here, params, that contains information that comes from this option. So let's have a look to see what it looks like. So I'm pressing the keyboard shortcut Shift-Alt-G to quickly jump to row 66. So params, if you run this line, you can see that it is a list, and a list that contains continent with each of the continents that are expressed at the top. Let's go ahead. Here you have continent. The choices are Africa, Americas, Asia, Europe, and Oceania. Let's go back again, and let's show you how 63 actually, how to use this. Okay, so that parameter could be changed to anything, and you could give your stakeholder the power to rerun your analysis with the parameters that they choose. So in this case, the challenge is the following. Edit the YAML header so that the param continent takes the value only Europe. And then here we will use that parameter to subset the data in your analysis with the value that the user gives. So you're adding a variable, as opposed to hard coding the continent, you are adding it as a variable that can be parameterized here. So here I'm going to change the value to just Europe. So these are all the choices, and the value is just Europe. But before actually I do that, let me show you what it looks like. So if I click here on neat in the drop-down menu, you will see that it says neat with params. Try that. And you see now that you have all the items that are listed here in choices. And the choices you can remove from here, right? And if I choose only Europe and create a report, now the report is not going to be about every country. It's going to be specifically about Europe, because we are about to do that on the code. We are about to filter it. So you create a report that is flexible enough so it allows your users to create reports for specific parameters. So in this case, for example, look at this figure. It looks one way, and that is the output of Europe. So let's change that parameter to a different one. Let's do Americas, Oceania, Asia, and Africa. Let's do everything and see what the plot looks like. It should look different. And it does. It has a lot more data points, right? So now you're creating an interface. You're not just creating a hard-coded report. You are creating a report with an interface for your stakeholder to produce the answers that they want, not the ones that you hard-coded. So how do we go about that? Okay, so let's go back to doing the task. So the task was set Europe here. And then we are going to line 63. That was to have a look at params. So now if I change, because I changed the parameter, the value to just Europe, notice how params now only contains Europe. What happens if I chose Europe and Oceania? And if I now go to line 63, if I run this chunk, now it is Europe and Oceania, right? So what I'm doing is that params is a variable. Remember that you can create a variable like this. So you store the value 1 to var, but you can also store a value to a variable in the header of a YAML file. And that is beautiful, because then a user can just by knowing about this button, they can knit with the parameters that they want. So that's what we are doing. We are exposing a variable from outside your code to the interface for users to run. So let's now, so how that magic works? Well, the way it works is that you use the values stored in the params variable, which were Europe and Oceania, but let's just change it to Europe. Right, so this should be also only be Europe, just to meet the expectations of the challenge. So we have done that, and now we have to filter the data that we have using filter to subset the rows only in the continent that comes in the parameter continent. So params is a list, and one item of the list is continent, $continent. So I say params $continent to access the values in it, which is in this case Europe, right? So I use exactly that. So let's use, so what we are gonna filter is gapminder as usual. So take gapminder and then filter where continent is in params continent. So this is the code that makes the magic happen, that makes the report produce something different depending on the input given to params continent, which in turn is something that a user can modify just from the interface, from the neat interface at the top. So that meets this challenge. So now, by running this chunk, I get only the continents, in this case Europe, and if I change here again to Africa, let's go to line, if I change to Africa, then what we see here should be Africa. You see? Nice. Europe. Let's go back to where we were. Okay, we met this challenge. Europe. So you have learned about filter, which allows you to select rows, to subset rows by the values that you choose. Now we are going to use another extremely powerful, that's called, in tidyverse jargon, it's called the main verbs. Filter is, along with select, one of the two most important main verbs. There are a few more that you're going to be learning about tomorrow. So select allows you to pick or drop entire columns in a data frame. So let's in this case, let's take before we created a data frame called filter, right? It's the output of having selected specifically, having filtered specifically those rows. And now we are going to continue to subset it, in this case, by excluding the column country and continent. How do you express that? Okay, you just simply refer to the column and add a minus at the front. So we take filter, which is the name of the data frame. It's no longer gapminder because we want to incrementally modify this object, right? So we take the filtered data frame and then we select. Actually, probably here this one was also a typo. We select the columns minus country and minus continent. So that way, what we do is we exclude. So there is no more continent or country columns in the data set, right? So filter to subset specific rows, select to select specific columns. If I set only country, for example, if I set this, then that's the only thing I get. If I set only continent, then I get country and continent. If I say minus continent, it takes everything else except that. And an introduction to what's called some helpers. So select comes with some helpers, something like everything. You can do something like this to select everything, or if I wanted to move the ER column to the front, I can say select ER and then everything else. And now ER comes to the front, right? So select is very powerful and it comes with a bunch of helpers like that, like everything that we will learn more about throughout the workshop tomorrow, that allow you to very expressively subset your data. That's the key message. So I'm rendering this every now and then so you see the updated output here. We have the YAML, filter, select, and next step. Okay, so now next step is to have a quick look at the relationship between two variables, GDP per capita, which is the how much money people make on average, and life expectancy. To explore what relationship we expect. And the way we're going to do that is we're going to use the template that you already know, but a different geom. In this time we're going to do points. So the template that you know was take the data, and so the first argument, remember, was data equals selected. So this should work, but I also told you that we are using the pipe a lot and it's good to become familiar with it, especially when it comes to mixing the pipe with the plus. That's very confusing, and that's why I want to expose that challenge right now, like up front. It is important to understand that the syntax pipe came actually after ggplot was developed, and ggplot2, that's why ggplot2 didn't know about the pipe because it hadn't been invented by the time ggplot2 developed. So instead they came up with the idea of adding layers with plus. But if ggplot2 was reinvented today, they could probably use the pipe as a way to combine layers. But it's too late. Too many people use it and love it, so they can't change it. So what we are doing here is we are taking the data and then we are using the template that you know about to map the variable life expectancy to the x. And I could be explicit about x, or I could remove it because it's so common that you will learn by heart that the first argument to AES is x, and the second argument is always y. So let's do y and x, which you can do. But then any other arguments that you might want to map are not easy to remember. You don't know the order in which they come. Actually, they can come in any order, and you have to explicitly say the name of it. So you could avoid X and Y, but you cannot avoid something like, for example, if you want the size of the points that you're going to plot to depend on the values of the column population, so you want bigger bubbles for countries that have more population and smaller bubbles for countries that have smaller population, then you can map the column pop to size. So let's have a quick look to the data. Pop is a column, so we can map that to size to create points of varying size. So that's what we are going to do. Let me run that first with nothing here. So let me remove this. So if I run these 3 lines first, what I get is it's an okay plot, right? I have, X maps to life expectancy here, Y maps to GDP per capita here, and the size of the population maps to the size of the bubbles. But what is the problem? Okay, there is a lot of overplotting. There is so much bubbles one on top of the other that I don't know what's happening in here. So one way in which we can address that problem is by by setting some parameters which is different than mapping. So geom_point, as Daisy mentioned before, could take, if you wanted, the argument AES itself, right? But it could also take, I'm just restructuring the coding here. So, but it could also set parameters outside AES. In this case, the parameters that we are controlling is alpha, which controls how dense the colors look like, and shape, which is if you want, for example, full bubbles or empty bubbles. So let me, for a moment, remove shape to show you this process little by little. So this is what the bubbles could look like if they just were 1/3 of opacity than they are originally. So 1 would be full black. 1/3 is only 1/3. And then the shape, I would prefer them to be empty so that I minimize the overlap even more. So this is the output that I created. Mapping life expectancy to X, GDP per capita to Y, mapping the size of the population to the size of the bubbles, mapping, and then setting outside AES 2 things: transparency with the parameter alpha, and shape, to tell that the dots, I don't want them to be full, but I want them to be hollow. And that is it. I think I'm gonna make a little mention here on iteration. Do we have questions on this? Yes. Mm-hmm. Yes. Yeah. Go with it. Yeah. It is kind of hard to remember. I have 2 recommendations for a very quick view. Maybe you just go to the help file and see the var aesthetics here. So each help file of each geom has an aesthetic section, and it gives in bold. It is a weird convention. In bold, it gives the required aesthetics. So you must give, if you're using geom_point, you must give X and Y. But also it has other aesthetics that you may want to know about: alpha, color, field, group, shape, size, and stroke. So that's the first place to go. And then the second place to go is go here, right, on the web point, because the website, the beauty of it is that the help file is rendered. When you ask for a help file in R, you don't get the output of the examples, but when the same thing shown on the website, so the help file is identical except that the examples actually run. So with a very quick scheme of this page, you say, this is what I want. I want colors for different things. That makes sense. What is that code? And then, okay, it is the argument color mapped within AAS. Or you keep screening and, actually I want transparency. What is that? Okay, it's the alpha set outside AES, right? So I recommend you to just very quickly, okay, these shapes here. How do I know which shape maps to each thing, right? Okay, so here we have shape. So shape comes from the value of this column, whatever that is. And there is 4, 6, and 8, right? So as you can see, it is such a powerful system that is also, it comes at the cost of some complexity, and those are the two advices that I have for you: website and help file. Any other comment? Question? Okay, so you've learned, again, we went through the whole little loop of importing data, visualizing data, but before doing that, we also transformed it. With select and filter. But in this section, it gets a little technical, but also responds to a suggestion by Jakob that to try and understand how to avoid for loops. So I think my goal for the actually, because we have 20 minutes, because that's the last section, so we're not gonna stop 10-2. So I'm gonna try push through this document. So I'm gonna talk about iteration. So before you selected the column country and continent, so you excluded actually by saying minus column name basically. But now we are going to do it a little different by thinking about what is the type of the column that we are working with, because I want to expose this idea that you can think of the problem of selecting something inside a data frame as an iteration problem. And this is only an excuse to start talking about iteration because we have to. It is a key component of every data science. Because it allows you to repeat things, to scale up, basically, to repeat things over and over and over again. So the key here is to try to do again this idea of excluding country and continent, but now we are going to use a different syntax. The syntax selects where and also the function keep. So let's see how that looks like. So we start from the same thing. We start from this filter data set that has a bunch of continents and a bunch of countries. And we want to select. And instead of saying, exclude continent, we are going to think of the type. So the type is this thing that comes here. So in this case, country is a character vector and continent is a character vector too. But if you keep moving, you will see that every other column is not a character vector, it's a double. Nice. So the two columns that we want to exclude, or we want to pick, in this case we're going to pick them, the two columns I want to exclude are characters, and everything else is numeric or double. So I could use, there is a function called isDouble, or is numeric, to make it easier, but I think there is double, so isDouble, yes, I think it should work. So you can use the helper function. Remember that before I showed you the helper function everything? Well, there is another helper function that's called where. Where looks at the type of column that you have, if it's character or if it's double or it's whatever. So I'm going to use numeric because I think it makes more sense. So it is obvious that country, Albania, and continent Europe, those are not numeric values. So what I want to do is to select columns where the column is numeric. That will automatically exclude the character columns, right? So let's run that. So that is selected one. So I'm storing the result in selected one. So as you can see, when I print the output of selected one, and how I'm doing that, I'm selecting the name of the variable that I want to select, pressing Ctrl and then Enter. As you can see, there is no longer any character column here. So what would you expect to happen if I instead said is character? So if I run this code, let's run this one. Now I only select the ones that meet this condition, is character. So this is a question that you are asking to the type of the column. Is character or not? If it is, select it. If it's not, drop it. So we're gonna keep to numeric. So this is, here what I'm doing is we are gonna compare, so that what you expect is that the same result that we did before by selecting with minus country and minus continent should be identical to what we get when we select the numeric variables, right? We are doing exactly the same thing. So if I say selected 1, which is the output done this way compared to the output done the other way, if I pipe that into identical, then I should expect an answer of true. I'm asking, is selected 1 identical to selected, to the first approach? And the two approaches are equal, so identical, so it should get a true. This is probably a typo. Selected 2. This time let's talk about concentration. With keep. Okay, so there is another function that does something very similar, which is the function keep. Keep comes from a package called pur inside the tidyverse, and it is it looks into a list in general, and the data frame is a special case of a list, by the way, and keeps only the columns that meet the predicate. So in this case, I could do exactly the same with is numeric. So before here, I used selected where is numeric, and now I'm using another function that does it even in a more straightforward way. Keep is numeric. The result is in selected 2, and the output should be identical to selected. Same thing. So what we are doing here is, although it is not obvious, it is an iteration problem. And for those who are fond of the for loops, or who come from programming languages where for loops are heavily used, let me kind of break that down to how on earth, selecting these two columns is actually an iteration problem. Okay, and how you could do it with for. Okay, so in a for loop, you generally, and it is good practice to start pre-allocating a vector that will contain the items that you want, so the results that you want to get inside the for loop. So what I'm doing here is I'm checking how many columns the filtered dataset has. So this is the filtered dataset, right? It has 1, 2, 3, 4, 5, 6 columns, right? So if I run this this code here, I should get a 6. So I'm creating a logical vector of length 6, and I'm calling it pick. So this is the vector that will hold every iteration of the loop that I'm about to start. So now, because filter is a data frame, it is also a list. So I can use this convenient function sekalong, which creates a sequence along the length of a vector. And a list is a special case of a vector. So sorry that for those who are not very used to the low-level details of R, I'm kind of throwing a lot of jargon that comes from data structures. I discuss what a column, what a numeric variable is. I discuss what a character vector is. I'm tapping into this idea that the data frame is also a list, and a list is also a vector. All of that, it can be very, very fast for you, but at some point I have to mention this is like a super speed workshop. So I'm creating a sequence from 1 to 6 with a very convenient function sekalong the length of a list, and the length of a list of a data frame of 6 columns is 6. So for each of these indexes, what I want to do is, in this case, take the data frame and subset this particular column. So take the first column first, and then check if it is numeric. If it is numeric, the object pick will be modified in place to change the value false, that is its original value, to true. And if it is not numeric, it will be updated with again. It will be again written as a false. So this object will change. Let me run this code from. So now I have run this loop, and now pick should have been changed. So where the data frame had a numeric column, I got true, and where I had a non-numeric column, I got false. So that's the new state of pick. And now I can use that vector pick to subset the data frame filtered. So if you run this code, what you get is exactly what you got before with the select where or with the keep approach. Why all this mouthful? Because I want to just demonstrate two things. One, that selecting columns could be thought as an iteration problem. And two, to also expose that there is high-level ways of doing things and low-level ways of doing things. And as you will read in a class, in another lesson tomorrow, someone has to write a for loop if the problem is an iteration problem, but it doesn't have to be you, because someone else already wrote a function like keep or a function like select where that does a for loop for you. So if you find yourself today writing a lot of for loops, it is very likely that you are making your life much harder than it should, and instead you should be probably learning about higher level approaches to achieving the same goal, because you will end up with less code, less error prone, faster to read, faster to write, and easier to understand. So I know that I might have hurt a lot of feelings here, because a lot of people do like working at the low level, and that's fine. As long as it works for you, it works for you. But for those who don't know, please be aware that there is many ways in which you can solve iteration problems, and not necessarily, and force should probably be the last resource. And just to kind of put the little cherry on the cake, in the same way that there is a function called keep, there is a function called discard, which does exact opposite. So if I say keep is character, it will keep columns of type character, and if I say discard, it will do just the opposite, right? So, by the way, when I was showing, every time that I was showing identical, so I was showing, for example, selected 4 is identical to selected, yes or no, selected 3 is identical to selected, yes or no, all that is repetition, right? And that is an opportunity to solve this as an iteration problem. And this is the little topic where I'm trying to advocate for how to solve iteration problems in an elegant way. And the answer comes from this idea of mapping different values of a vector. So this is a vector, and mapping different values, this value, this value, this value, and this value, to a particular function. So the answer to solving a lot of iteration problems that people tend to go to for loops can be resolved at a higher level and in a more expressive way with this idea of mapping. In the same way that you map, say, a color to a country, you can also map any element of a vector to a function. And with the function map, it is as simple as that. You take the vector and give it a function name, and map will be in charge to applying that function for every element of the object. So that's at the high level how it works. Let me show you some concrete example. Okay, so say that we want to solve the problem that I mentioned before. So I compared the object selected 1, selected 2, selected 3, and selected 4. Every time before, I use the function identical to compare one to the other. So I was doing this. I was manually calling the function identical, with each of those elements against selected. And what I want now instead is to do that within map. So I'm just going to use the function map, or a flavor of it, to do the same thing in a way more elegant way, without doing copy paste, which is what I did, or using a for loop. So the first thing you do is you start creating that vector that contains the things over which you want to iterate. So this vector, right? This vector or this list is the same thing. Not the same thing. So a list is one kind of generalization of a vector. So we have now here this list is called to compare. Let's see what it looks like. Basically, it is, for each of these boxes here, I have a data frame, right? Which is each selected 1, selected 2, 3, and 4. Remember, those are just data frames that were selected in a particular way. The key of what I'm trying to demonstrate here is the iteration problem. It's not so much the task of selecting that we did before. So I already have my list, right? I already have this. So now I use the function map and the function that I want to apply, which is in this case identical. So this is how it works. So I take the list that I created to compare here. So this could go, in the example that you saw in the figure, the way it is expressed is like that. Right? So you have the mapping function, and I'm going to explain this other part soon. And you have the list and then the function that you want to apply. So you map a list to a function. But this function, identical in particular, probably it was too tough of an example to show you first, has 2 arguments. So identical doesn't take just 1 argument. Identical takes 2 arguments because it wants to compare the thing to the left with the thing to the right. But we want to do one by one. So this against this against this, and this against this, and this against this. So we do that with the mapping function. So to compare the list, in this case, we pull it out of the function and we call it as a pipe. And then the function that we want to apply, identical. And any extra arguments that you need to pass to the function, you can pass them with a comma after the function name. So this is the result. So I run that, and you get true, 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 and true. In the example above, I mentioned the map function. And the map function would just work. It's just that the output is kind of awkward. It is a list. So the output of map is always a list, as opposed to the output of the different flavors of map. Map comes with many flavors. Let me show them. Map add, map character, map double, map df, map. So for different jobs, you may want to use different map functions. In this case, the output that I want to get is a logical vector. Therefore, I use the flavor logical to get a nicer output. So instead of getting a list, I get a single vector that is a logical vector. So that's the end. Here is where I was asking you to, at this point I was going to ask you to create a parameterized report with the need params, but I already showed that, so I kind of went ahead of myself. And instead I'm going to jump right away to the takeaways, which will close this lesson and will close also the first day. So takeaways for today, and actually before I do that, let me commit my changes. So I'm going to select all files, click a box to check them all, write commit, and solve scooter. Click commit. I can also avoid writing a message, a body message, if I don't need to. And then in the console, as usual, I'm going to run pr push, and I'm already updating my pull request. So with this, I also show you that working with Git and GitHub should be fluent. So once you have this set up, how much was that? Like 5 seconds, 10 seconds to work with Git and GitHub. So I know that many have experienced a lot of pain, and that also generally suggests that there is something that in your workflow that could improve. So going back to the takeaways and to wrap up the day. So when you import, it is very usual that you will inspect your dataset so that you quickly have an idea if there's anything wrong with it. Glimpse is a friend of you. You can also use the function view, or you can use just the table output to the console. In the transformation of data, two of the most important functions come from a package called dplyr and are filter and select. So filter allows you to subset rows using column values, and select allows you to select columns based on their names and also their types, because it comes with a bunch of helpers that perform iteration problems inside select. As opposed to you writing for loops, I recommend you to think of the problems that you have at hand and see what are kind of more expressive ways of solving that problem. For example, using the where function inside select will perform an iteration solution inside your data frame and keep only the columns that you choose. The same thing you can do with other functions that come from other packages like keep and discard that also come from the tidyverse. It's just not dplyr, they come from a package called pour. In visualizing, we learned that it is a different thing to set parameters and to map parameters. You can map the country names to different colors so that your single plot shows the dimension of the country. But you can also set the color to blue, to pink, whatever, and every point, regardless of the country or the continent, will be the same. So you can also you can map things not just to X and Y, right? So you can also map size and color inside the aesthetics. And thanks, Daisy, for your question. You learn about the aesthetics in the help file. There is a section dedicated to aesthetic. They come in bold if they are required, and they come in just plain text, normal text, if they are not required and optional. And also I recommend you skim the help file of that function on the website of the ggplot2 reference, because the examples will be run, and without you running them, you can very quickly know visually what you're looking for. In communication, rmarkdown is your friend. The params feature is very powerful, very little used. You may have heard of Shiny apps. Well, the power of parameterized rmarkdown reports comes from Shiny. Internally, it is calling Shiny to create, for example, that interface that your user uses. But Shiny is a very powerful and complex framework. So if you want to leverage some of the really cool features of Shiny in a very easy way, use parameters. They give you for almost free a lot of power. And finally, and the takeaway of the iteration part, the for loops are good. You can use them, are totally fine, but they are very low level. It may take a long time to write. There are some, you may need to know how to use them to make your code run still efficiently, because there is room for mistakes. And instead, you may be looking at solving the same iteration problem at higher levels using functions like map or using functions like where inside select. That's the end of the day. I acknowledge everyone might need to go home now, but I will be around 5 minutes if you have questions. You're very welcome. I'm recording, all these recordings will be here for you to visit later, also for you to recommend if you think that someone in your team could benefit from knowing the practices that you now know. Also, the repository hopefully will live there forever, so the documents that you have now are also available for you and for people who, it is good to be in the same page, so now you have a lot more skills. You may find yourself having a lot more skills than people are working with you, and you may now realize how much more they could get and how much better they could work with you, and they can make your life easier if they learn a little bit about this. And you've learned all of this in just 4 hours. So tomorrow we're going to get even deeper. But even if you stop today, what you've learned should at least give you the tools for you to learn more whenever the time comes that you need more. Otherwise, you just keep going with your life. So thank you very much. Today I'm going to update the repository to show the latest versions of the lessons that we're going to cover tomorrow. And I anticipate that I won't be able to cover everything, and thus I'm going to just record it and leave it there for the future. Thank you. Bye-bye. Thanks, everyone.